This is the true story
of 9 different planets who were picked to live
with one another
in one solar system
and have their lives taped.
Find out what happened.
The planets stop being a mystery
and start being real.
The real worlds.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
Bill.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by a grant from the Copernicus Foundation, putting the Earth in its place since 1543.
I'm talking to you from the only place we know of where there are living things like you and me. You're alive, right? That's because you're living on the planet Earth. Altogether, there are 9 planets. And they all go around the sun in the same direction. If we could get way above the Earth's North Pole, we'd see that they all go this way, the opposite of the way a clock turns, what we call counterclockwise. They're all part of what we call the solar system. Now take a look at this. It's a picture of the sun on this television, and it's part of our solar system model of science. Now, right here is the first planet, Mercury.
Mercury, the second smallest planet. It has no moons, but plenty of heavy metal.
It's like a hot rock. As we move away from the sun, we'll pass the other planets. There's Venus.
Venus, a real hothouse of value. Also no moons, but plenty of toxic yellow clouds.
Because of its thick atmosphere, it's the hottest planet in the solar system. And there's our planet, the Earth.
Earth. 1 moon, protective atmosphere, and liquid water. Need I say more?
And here's Mars.
Mars. Big, red, and dead. 2 moons and full of iron oxide.
Somewhat cooler than the Earth. And out here farther is a very large ball of gas we call the planet Jupiter.
Jupiter. The largest planet of them all, 16 moons and 1 big red spot.
And if we keep going, we'll pass another giant ball of gas, Saturn. It's the one with the big flat rings.
Saturn. Rings, and at least 18 moons.
Out farther and farther from the sun, we pass Uranus, which has very thin rings.
Uranus? The sideways planet, blue with over 14 moons and recently discovered rings.
Out farther, Neptune.
Neptune. 8 moons and cold.
And finally, way out here is the very small planet, Pluto.
Pluto. Last and smallest planet with 1 moon. The end. Or is it?
Now out here, it's very cold. Look how small the sun is, way off in the distance. Now planets in close to the sun are much warmer. So out here it's cold, in here it's warm, and the Earth is just the right distance from the sun to keep living things like you and me alive. You're alive, right? When we show models or pictures of the planets, we usually show all of the planets at the same time. But with the real planets, that's very hard to do because the real planets have a lot of space between them. No, I'm not kidding. I mean, a lot of space. A lot of space. Okay, let's say that this balloon is the sun. It's a little over 1 meter across. Then the planet Mercury would be here, 39 meters away, and would be just about this big. That's all there would be to the planet Mercury. Here, at 72 meters, that would be Venus. Now, the sun's still behind us. And look, up here at 100 meters, our own Earth. Hi, everybody.
Hi, Bill.
Now we got to get serious.
Uh-oh.
There's Mars. Now the distances start to get very large. Those planets, those models, are the actual size. Now the sun's still back there. And here's Jupiter, 520 meters from the sun. That's over half a kilometer. And Jupiter would be about this big. Isn't that wild? Here's Saturn, the one with the big rings. 953 meters from the sun. Almost a kilometer out. Way out here. And this would be Uranus, almost 2 kilometers from the sun. It's way out here. Are you beginning to get the picture? Everything is really far apart. There's a lot of space in space. Things are really far apart on this model. That's because everything's to scale. That's why we don't always make models like this to scale, because they're huge.
Are we there yet?
Here's Neptune, an icy blue planet, 3 kilometers from our weather balloon sun. It's got to be around here someplace.
Down here, Bill. Bill, down here.
Oh, there it is. Oh, yeah. Piece of cake. Here's Pluto, 4 kilometers from our sun. Pluto is 40 times farther away from the sun than our Earth. It's over 6 billion kilometers from the sun. Do you get it now? The distances between the real planets in real outer space are huge. Huge.
In this model, the planets look rather close to the sun.
Huge.
But actually, millions and millions of miles away from the sun.
Outer space is spaceship.
If a rocket were to set out from the Earth, traveling through space at the rate of 1,000 miles per hour, it'd take more than 10 years to reach the sun.
It's hugely big.
If the same rocket were to set out Pluto at 1,000 miles per hour, it would take almost 450 years to reach the sun. All of the stars, including our sun, give off their own light. But a few of those bright spots in the sky are not stars. They shine only because they reflect. They are called planets.
Hi, folks. Looney Worthington and Looney Worthington's Miles and Moons, ready to make you a deal that is out of this world on moons. From the one that started it all, the one that causes the tides, the one that goes round and around the Earth, the moon.
The moon looks like the biggest thing in the sky, doesn't it?
No magnetic fields, no signs of life, no water. Hey, this
Not
baby's
this guy
ready to
again.
sell.
There's a lot of wackos in a city like this. Most of the time, you chalk it up to the moon and don't ask questions, even if you don't know where it came from. My name's Luna, Luna Van Dyke. It's a Dutch name that means elliptical orbit. I'm a detective.
Relax, Luna. It's just me, Lou. Lunar.
Lunar? I haven't seen you in a blue moon.
Don't act so surprised, Moonchild. We have some unfinished business. You were supposed to tell me where the moon came from, unless you conveniently forgot.
Easy, big boy. Luna never forgets. You see, there are 4 basic theories of where the moon came from. The first is that it was a part of the Earth that broke off. Or there's the theory that it was a small planet that got trapped in the Earth's gravitational pull. Or there's the theory that it's a whirlpool of dust and gases left over from the making of the sun. There's even the theory that a comet collided with the Earth and pushed materials into outer space. No one knows for sure. All I know is it makes me hungry.
Mighty impressive, Luna. Come on now. Treat you to a moon pie.
My name is Ellen Howell, and I'm an astronomer. I use telescopes like this one here in Arizona to study asteroids, bits of rock floating around in space. And these are the materials that went into forming the Earth and the moons and the other planets in our solar system. We want to know what they're made of, we want to know where they are, and we want to know mostly if they're going to hit the Earth at some time in the future. If an object a few kilometers across comes hurtling in at 15 kilometers a second or so, it's going to hit the ground and there's going to be a huge explosion and it's going to leave an enormous hole. And a really big explosion could change the whole climate of the Earth. And so that's one of the things that people who discover asteroids are very interested in, is trying to find where they are and predicting where they're going to be many decades into the future.
Planets and moons shine by reflected sunlight.
We've laid out a model of the solar system on this field that's a couple hundred meters long. So look, there's Mercury, Venus, our own planet the Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Now notice, we wouldn't see any of these models. We wouldn't see any of the planets without light from our searchlight sun of science. Without light from the sun, the planets would completely disappear. Without light from the sun, the world would be cold and black, like space.
This observatory here was built about 3 years ago by students from our own school. It was built with hard work, sweat, labor.
The more you tighten it,
Yeah.
the less it moves.
Right.
We got an 18-foot dome. We got a 10-inch telescope here, a couple of CCD cameras, a computer-aided telescope.
It's just a CCD camera, and you attach it to the lens of the telescope, and then you attach it to the computer, and then you get Jupiter on your little small screen.
Got the winches here to pull the dome around either way.
I think on a satellite. Oh, check it out, looks cool.
The Earth's orbit is round, but it's not a circle. Please consider the following. You might think that Earth's orbit would be round, like a soccer ball, like that. But it's not that perfectly round. Now, it's more like a football, with the ends squashed in a little bit. Now, this shape, the shape of planetary orbits, is what scientists call an ellipse. Now, let's say that this is the sun, and we're going to draw the Earth's orbit with the point of this pen. Now, if the Earth's orbit were a circle, you could draw it just like this. Draw a nice round circle. But the Earth's orbit isn't like that. It's a little more complicated than that. There's another point over here someplace. And the string connecting them is much longer. Then, as the Earth goes around the sun, it makes a shape like this. Now that's an ellipse. Now look, when the Earth is farther from the sun, it's going slowly. When the Earth gets close to the sun, it speeds up. Slow, fast. Slow, fast. Slow, fast. Now these 2 points are called the focuses, or foci, of the ellipse. Now this is the sun, and this other one is just a theoretical point out in space. Slow, fast. Thank you for joining me on Consider the
And if you act now, I'll toss in a commemorative Neil Armstrong action figure. Or how about some pretty rocks orbiting Saturn? So, for a deal that is out of this world, take one small step to Looney Worthington's Miles of Moon.
Psst. Bill. Bill. Hey, science guy.
Oh, hi. I was just, well, anyway.
Yeah.
Gravity between dust particles in space made all the planets end up going around the sun in the same direction. They're revolving around the sun, counterclockwise. Let's say that these 2 magnetic marbles are like dust particles.
Okay.
Now watch. Let's say they're drifting through space, and they come near each other. Sometimes they go right past each other, like that. Sometimes they bounce off, like that. But sometimes they come together at just the right angle to start spinning. Like that, see that? See, they're going counterclockwise. Ooh, that was a good one.
Mars is called the red planet because it's covered in rust.
You can make your own red planet. Just fill a baking pan almost to the top, full with sand.
Cut some steel wool into a bunch of 2-centimeter pieces. I'm wearing gloves because steel wool has some prickly points.
Mix the steel wool in with the sand.
Now, add water so that the mixture is barely covered.
Put it in a safe place. And check on it every day. Add water to keep it moist.
The water causes the steel wool to rust. As it evaporates, the steel wool leaves rust deposits in the sand.
Eventually, the sand will turn red, just as it did on Mars. But don't take our word for it. Try it.
Do you notice that the planets that are closer to the sun move about it much more quickly than those farther away?
Gravity is the glue that holds our solar system together. Gravity pulls on the planets and keeps them in orbit, the same way this rope pulls on this ball.
It actually takes Mercury, the planet closest to the sun, only 88 days to go completely around it.
Now, when planets are close to the sun,
that's about as long as your summer vacation.
They spin around faster than when they're farther away.
Our Earth goes about the sun once each year.
That's because even though they're going fast, they have a longer distance to go when their orbits are bigger.
And the planet farthest away from the sun, Pluto,
you with me?
Naturally has the greatest distance to travel.
You see what I'm saying?
It makes the trip around the sun in about 248 years.
You with me? Okay. Oh, if you could get above the solar system, way out in outer space, above the Earth's North Pole, and then look down, you'd see that all the planets go around the sun in the same direction, this way, counterclockwise. You'd also see that they're all in the same plane. They all go around as though they were on a tabletop. All of them. We got Mercury.
Plenty of heavy metal.
Venus.
A real hothouse of value.
The Earth.
Earth, protective atmosphere and liquid water.
Mars.
Big, red, and dead.
Jupiter,
the largest planet of them all. One big red spot.
Saturn.
Rings.
Uranus.
The sideways planet.
Neptune.
Cold.
Pluto.
Pluto, last and smallest planet with one moon.
They all go like this, counterclockwise. So if you're standing here in the middle, you're like the sun at the center of the solar system. And the sun rotates too, like this, counterclockwise. They laughed at me when I suggested that we have 9 trains for 9 planets, all going around the sun counterclockwise. Wah-ha-ha-ha! Wah-ha-ha-ha!
Bill?
Wah-ha-ha-ha!
Bill?
Planets of Parking! Parking with the planets!
Hello, Hal. Do you read me? Do you read me, Hal?
Affirmative, Bill. I read you.
Hal. Open the pod bay doors, Hal. Hal. Open the pod bay doors.
I'm sorry, Bill. I'm afraid I can't do that.
Hal. I need you to open the pod bay doors, Hal.
I'm afraid I can't do that, Bill. This show on the planets is too important for me to allow you to jeopardize it.
Hal.
Goodbye, Bill.
Produced in association with the National Science Foundation.
Yeah, it's a great day for training in the space shuttle. Come on!
Security to the shuttle. Security to the shuttle. There is a situation in the shuttle. Come out with your hands up, and you won't be hurt. Much.
Daisy.